When we talk about ratios, we just mean simply that the ratio of one number to another is the first number divided by the second number. So, for example, you might see A to B written as A divided by B, or as a fraction that's not in line, A over B. So you're simply just taking A and dividing it by B. We can express ratios here with creating fractions. So the ratio 12 to 8, you can think of that as 12 divided by 8, which as a ratio would be 12 over 8. You can simplify these ratios by using your rules for simplifying fractions. In this case, both a 12 and an 8 are divisible by 4, which means this simplifies to 3 over 2. The ratio 2 to 9 would be written 2 over 9. That cannot be simplified since 2 and 9 don't share any factors. And then finally, the ratio 10 to 2, we would do 10 over 2. And even though 10 divided by 2 is 5, to keep this as a ratio, we would want to keep that 5 over 1 to imply that this is a 5 to 1 ratio. Now we can apply this to scenarios that you might encounter. So perhaps you have a room that is 18 feet on one side and 12 feet on another. If we wanted to make the ratio length to width, that would be 18 over 12, which simplifies to 3 over 2 since 18 and 12 are both divisible by 6. Now we need to be careful with ratios because sometimes we don't have the same units. So for example, instead of knowing that the width was 12 feet, what if we knew instead that it was 4 yards? That's an equivalent measurement, but here we would be looking at the length of 18 to a width of 4. But this time our units are very important. If we were to write 18 feet over 4 yards, that would be a difficult ratio because we aren't comparing the same units. So you would not want to give this ratio for most cases. Typically, you would want to convert this to 18 feet over the equivalent 12 feet so that you can just describe this 3 to 2 without units. But, like I said, not all ratios have to have the same units, particularly in things like slope or pipe specifications, looking at the slope of a ramp, the slope of a road. Sometimes those will be measured in the feet over a certain number of miles or the inches over a certain amount of feet. So for example, if we had a drainage pipe specification where the slope was 1/4 inch for each foot of horizontal distance, you would not want to convert this. 1/4 inch is really small compared to a foot. So you would keep this ratio, but the way that you would write this is by looking at your units inch per foot. So in example 2, we certainly could have done 18 feet for 4 yards, but that just doesn't make as much sense in the context as it would for something like number 3. Number 2 was easy for us to get the same units, and they were relatively similar in size. But for specifications like you see in number 3, where you're comparing something small to something relatively large compared to it, I would recommend keeping the ratio as 1/4 inch per foot